All right, ready for this. Bacteria powered lasers in space. Sounds like we're about to dive into some sci-fi flick.
I know, right? But what's wild is this isn't science fiction at all.
This is for real project.
Yeah.
With funding.
Yeah.
And it could totally revolutionize how we power spacecraft.
I think what's so cool about this is how simple it is. Like, we're talking about using something that's been around, what, billions of years? Photosynthesis. Using bacteria to, like, make a renewable power source for space exploration that can replicate itself.
Bacteria, they're tiny,
All right.
but they're really good at, absorbing sunlight.
Oh, they are. They have these little antennae that grab almost every photon.
Every single photon.
And that's what Project APA
It came behind this whole thing.
Yeah, they want to take those antennae and use them to, like, funnel sunlight into a laser mechanism.
Wait, lasers need a gain medium, don't they?
Yeah.
Something to make the light stronger, so what would that even be here?
That's the cool part. The energy from the sunlight, the stuff the bacteria capture, that acts as the gain medium.
Oh, so it's like...
It's kind of brilliant.
It's almost too simple.
Right.
And since bacteria can multiply...
Totally.
We could just grow this power source in space.
Exacts.
Fewer launches, less stuff to ship up there.
You got it.
Way more sustainable in the long run.
And think about all the satellites going up these days. We need some serious power solutions, long-term ones.
Okay, so they've got the bacteria, they've got the sunlight. How does all of this compare to the solar panels we're already using, like the ones on the ISS and stuff?
That's the big question, isn't it? Right now, silicon solar panels, those are the standard ones. They're way more efficient. Like, they can turn about 30% of sunlight into electricity.
30%.
While these biosolar panels, we're looking at maybe 10, 15% for now.
So less efficient. Is that a deal breaker?
It's not so simple. I mean, think about it. Evolution has had billions of years to perfect photosynthesis, right? To get to that level of efficiency right away is a tall order.
Yeah, that's true. But even at, what, 10, 15%?
Even at that level, there are some huge benefits.
Okay, what kind of benefits, besides not having to launch a gazillion solar panels into space?
Well, the design is simpler. You don't need all the fancy electronics and heavy batteries. And there's that self-replication we talked about. All that makes these biosolar panels super attractive, even if they're not as efficient at first.
So it's a trade-off. Okay, this is all very cool in theory. Are there actually scientists, like, working on this in a lab somewhere?
Oh, yeah. This isn't just some, idea on a whiteboard somewhere. Project APACE is real, it's got funding, and it's international.
Like, a bunch of countries are involved.
Yeah, they've got researchers from all over Europe working on it.
So are they, like, growing some kind of tiny bacteria-powered laser in a lab right now?
That's exactly what's happening. They're testing it out, simulating space conditions and all that.
To see if it'll actually work?
Yep. And if it does, then it's on to building a real prototype for space.
So this is phase one.
You gotta...
Proof of concept.
That's how it usually goes with science, Gotta take it step by step.
And it sounds like they've got some serious cash behind them. What was it, like €500,000?
476,000 euros, to be exact, just for this first phase.
That's a good chunk of change.
Oh, yeah. And getting a prototype into space, well, that'll take way more money.
Obviously, space is expensive.
It always is. But first, they have to prove it works.
Okay, so what kind of bacteria are we even talking about here? Are we talking about, like, the stuff growing in a petri dish?
Not quite. They're trying out different types, even some real tough guys called extremophiles.
Extremophiles?
Yeah, these guys can live in some crazy places, like where there's hardly any light.
Oh, wow.
Some of them can absorb almost every photon that hits them.
That's pretty impressive.
Yeah.
So they're looking at these extremophiles, the ones that thrive in low light, for this project.
Yep. Because in space, even sunlight becomes a precious resource, right?
Right, it makes sense.
So using bacteria that are already good at surviving in low light, pretty smart move.
It really highlights how clever this whole approach is, Using what nature's already figured out.
Yeah.
To solve our problems in space.
Exactly.
Are they just using, like, natural bacteria, though?
Yeah.
Or are they, like, messing with them in the lab, too?
They're exploring all options. Natural, artificial, you name it. They're even looking at nanoengineering, making artificial antenna structures to see how they compare to the natural ones.
So they're running the whole
So you need
experiment,
to cover all the bases.
using what nature's got and trying to recreate it.
That's science.
That's pretty cool.
Mm-hmm.
Okay, I gotta say, this bacteria laser thing is way more interesting than I thought it would be.
No, right.
But before we get too carried away here, let's bring it back down to earth, pun intended.
Yeah.
What are the big challenges here? What are they struggling with?
Well, as we said, the efficiency thing is a big one. They're not as good as regular solar panels just yet.
Right.
And then there's the fact that we're dealing with, living things here. Keeping those bacteria alive and happy in space, that's no easy task.
Space is brutal, man.
It is.
Radiation, crazy temperatures, no gravity.
It's a wonder anything can survive out there.
So huge potential, but also huge hurdles.
Yeah. They'll need to protect those bacteria, keep their little photosynthetic machines safe from all the dangers of space.
Makes sense, because a dead bacteria isn't going to power any lasers.
Nope, not at all.
So they've got the funding, they're doing the testing, and they know it's going to be tough. What's next for Project APACE? Like, what are they aiming for?
Well, if this first phase works, if they can prove they can actually make a bio-solar panel here on Earth, the next step is getting the money to build a real prototype for space.
That's the big leap.
It is. They'll have to scale everything up, make sure it can survive, launch, all that jazz.
And launching stuff into space, that's the pricey part.
Oh, yeah. That's where most of the budget goes.
But if it works, the cost savings down the line could be huge, right?
That's the idea. Lighter payloads, less frequent launches, a power source that can basically make more of itself.
So it's a long game.
It is.
High upfront cost, but big potential payoff.
Huge potential.
And it's not just about powering satellites, right? What else could we use this technology for?
That's where it gets really cool. Imagine beaming power down to a moon base.
Whoa.
Or a rover on Mars. We could power habitats, science equipment, even vehicles.
Okay, now we're talking.
Right.
This isn't just about visiting other planets anymore. It's about, like, staying there,
Exactly.
building a real human presence beyond Earth.
That's the goal. And it all starts with these little bacteria. It's amazing what nature can do when we work with it,
All right, let's take a quick break. When we get back, we'll dive deeper into what this tech could mean for the future of space exploration.
It really makes you think, Something so tiny could have such a big impact on something as huge as space exploration.
It's like, what are the big things come in small packages? But here, those packages are microscopic.
Right. And this project, I think it shows us where things are headed in space. It's all about sustainability.
And being able to take care of yourself, not always relying on Earth.
Exactly. It's not just about getting out there. It's about staying out there and doing it in a way that doesn't, mess everything up.
Okay, so we've talked about how it works, the benefits, the challenges. But what about everyone listening? Why should they care about, bacteria-powered lasers in space? What's the big deal here?
Okay, this is where things get really interesting. Because this isn't just about space. This could actually change how we live and work here on Earth, too.
Hold on, how do we get from bacteria in space back to, like, life here?
Think about the core problem we're trying to solve here. Capturing energy and converting it efficiently. We're always trying to figure that out, whether it's solar panels or wind turbines, or even how plants do their thing.
Oh, I see what you mean. So if these researchers can make these biosolar panels that are super efficient and they can replicate themselves.
Bingo. It could be massive. Imagine solar panels that are lighter, cheaper to make, and last way longer.
And maybe we wouldn't need to use all those rare earth metals or complicated manufacturing processes. That would be a game changer, especially as everyone's trying to go green.
Exactly. It raises a really interesting question. Could what we learn in space actually end up solving problems back here at home?
Okay, mind officially blown. But we got to be realistic, right? This tech is still pretty new. What are the next steps for Project APACE? What's on their to-do list?
First things first, they've got to prove it works. That's this whole phase 1 thing. Can they actually get these photosynthetic antennae out of the bacteria?
And can they build a system around them that works?
Right, and can they generate a laser beam? It all has to happen here on Earth first, simulating space conditions, of course.
So they're, like, blasting these bacteria with radiation and freezing them and all that?
Pretty much. They need to know how these biosolar panels will hold up in space with the temperatures and the vacuum and everything.
Okay, so let's say phase 1 is a smashing success. What happens next?
That's when things get tricky and expensive. Going from a little proof of concept to a full-blown prototype that's ready to go to space, that takes some serious cash.
Because launching stuff into space is not cheap.
It's like the opposite of cheap. It's astronomically expensive, pun intended.
Nice one.
And that's the big hurdle for, well, pretty much anything we want to do in space.
But if Project APACE can show that this tech is viable, that it has real potential,
then the money might start flowing. Governments, private companies, who knows?
fingers crossed. Because the possibilities are just too cool to ignore,
I agree. It really makes you think differently, doesn't it?
Totally.
It's not just about the tech itself, it's about how we approach problem solving. It's about opening up new ways of thinking.
All right, so let's do a quick recap. We've got bacteria with these amazing antennae that can soak up sunlight.
And we can use those antennae to power a laser, making a biosolar panel that's super sustainable and can basically make copies of itself.
We've got Project APACE, an international team of brainiacs who are working on proving that this can actually work.
They've got the funding, they've got the plan, and they're in the middle of testing it all out right now.
The potential uses for this tech, forget about it. Powering spacecraft, beaming energy to moon bases.
Revolutionizing energy production back here on Earth.
It's like proof that biomimicry, looking at how nature does things, could be the key to, well, pretty much everything.
It could be.
And it shows us that space exploration isn't just about rockets and astronauts.
It's about pushing the boundaries of what we think is possible.
It's about benefiting all of humanity, using the knowledge we gain out there to make life better down here.
And it's a reminder that sometimes the most radical ideas, the ones that seem like they came straight out of Star Trek, are the ones that could change the world.
Now, before we wrap things up, I want to leave you with something to think about. What other things in nature, what other biological processes could we use for space exploration?
Ooh, that's a good one. What if we could use microbes to make biofuels in space? Or to recycle waste to make oxygen? Maybe we could even engineer bacteria to, like, make building materials or terraform a whole planet.
Whoa, no, those are some big ideas. But it all starts with curiosity, right? With being willing to look at the world around us and think, what if?
Exactly. So keep those questions coming and never underestimate the power of a good idea, no matter how small or weird it might seem.
This has been The Deep Dive. We've been exploring the crazy world of bacteria-powered lasers and what they could mean for space exploration. Until next time, keep looking up at the stars and keep wondering what incredible possibilities are out there waiting to be discovered. All right, we're back, and I gotta say, this whole bacteria laser thing has really got me thinking.
I know, right? It's such a wild concept, but it makes you realize that nature, it already has the answers to so many of our problems. We just gotta, pay attention and learn from it.
Totally.
Yeah.
And that's what I love about these deep dives. It's not just about, like, facts and figures. It's about seeing things in a new way.
Exactly. It's like biomimicry, right? Taking inspiration from nature to
Yeah.
solve human problems. And space is the perfect place to try this stuff out.
Because it's so extreme.
Exactly.
You got to be resourceful, you got to be efficient,
Totally.
and you got to think outside the box. And that's where biology comes in.
It's had billions of years to figure things out.
Exactly.
Evolution has had a good run,
Yeah.
So when we look to nature for ideas, we're tapping into this huge library of knowledge.
And in this case, that library might just hold the key to powering our future in space. And who knows, maybe even making life better here on Earth.
Think about it. If we can make these biosolar panels work in space where things are, super tough, why not here?
That's a great point. We're already seeing more and more bio-based technologies, right?
Hmm.
Biofuels, bioplastics, all that stuff.
This could be the next big thing.
It's like this whole deep dive has opened up a new world of possibilities. It's not just about space exploration anymore. It's about the connections between science, technology, and nature.
And it's about remembering that sometimes the smallest things, like tiny bacteria, can have the biggest impact.
Well said. I think it's time to wrap up this deep dive. We've explored this amazing technology, learned about the challenges, and imagined the possibilities.
We've talked about the research, the potential, and what it all means for the future of space exploration, and maybe even for life here on Earth.
But this is just the beginning. We encourage you to keep learning, keep asking questions, and keep exploring the incredible world around us.
Because who knows what other amazing discoveries are out there waiting to be made.
That's it for the deep dive. Thanks for joining us on this journey into the world of bacteria-powered lasers in space. Until next time, keep looking up at the stars and keep wondering about the incredible mysteries that the universe holds.